So for those of you who may not be familiar with Open RAN, it is a technology that's been gaining a lot of traction in the telecommunication industry over the past few years, and now the organization is bringing here it in the Philippines. So Open RAN is all about breaking down the traditional closed and proprietary systems that have dominated the industry for decades. So if you are working in the in telco, you will see or see a lot of this RAN and how they are built as of this moment. But since we are now upgrading and innovating a lot of technology, so with Open RAN, instead of having the traditional ones, we are building an open and interoperable networks that will allow um, um, to open for greater innovation, flexibility, and cost effectiveness. So in these courses or the all the series of courses that we have here in the Asia Open RAN, we will be taking you a deep dive into the world of Open RAN, exploring from its history, its key concepts and principles, its practical applications in real world scenarios. So I think if you're a student or a professional who wanted to upskill, this is a good venue for you, and has something to offer for you in the near future. So I think without further ado, so let's move to what we have today for today. Okay. So the topics that I will be discussing today is all about the radio access network. So we will have an introductory for this topic, the wireless telecommunication system components, the electromagnetic spectrum, and some of the key learning points by the end of the session. Okay, so let's start with the introduction to the radio access network. So I think a lot of you know, maybe not everyone know what is RAN or the radio access network. So if you're traveling or somewhere or just looking around, you will see a lot of these, and these are um uh things or buildings or towers that you will see, or what we call cell sites. Okay, so as you can see on your screen, we have a photo. These are cell sites that are strategically placed across a geographic area to ensure that your mobile devices or our mobile devices within the network coverage area can connect to the RAN and and access the network services that we are using. So the RAN or the radio access network connects all the mobile devices to the network and thereby offers mobile network coverage. So if you will take a look at an operator's mobile coverage as an example, you can see here on the screen that we have different color codings or technologies that are existing around. So these color coded system illustrates different technologies that are present in different areas. So some locations here, you can see a lot of 5G, 4G, some have 2G, but majority of these in the photo are covered by the 4G. And now I think we have a lot of deployed 5G networks around us already. So the location and the distribution of these radio access network facilities are critical, so we can have that mobile network coverage. So in the Philippines, so we have 2G, 3G, and 4G or 5G technologies that are existing as of this moment. Okay, so let's break down the radio access network. So the radio access network, so this is what it looks like, is strategically placed, just like what I've said, to provide coverage to users. The users is us within a specific geographic area. So the placement of this RAN components, such as the cell sites, are critical so that we can have a reliable and a consistent access to the network services that we need. So this is a very critical point for us engineers, designers, or the people who plan out where where to locate this RAN, because us users, we always wanted to have that reliable connection to our providers. So when planning the deployment of this RAN, different network operators consider a lot of factors. So this could be, for example, population density, or gaano ba karami yung tao or yung users sa isang lugar. So we also consider the topography, yung location mismo, building density, ma-building ba, or the location has only houses, traffic patterns within the coverage areas. So by analyzing these factors, our network operators can determine optimal locations and configuration of RAN components so that we can maximize our coverage and the capacity of our RAN. So for example, we have in the urban areas, so in the urban areas we have high population density and building density. So our network operators may need to deploy more cell sites with lower output, so to provide coverage to smaller areas. While in rural areas with lower population density, network operators may need to um, build or deploy fewer cell sites with higher output power, so that they can provide coverage to a larger areas. So the placement of this RAN is affects the overall network performance, such as the quality. So yung data speeds, so very critical tayong users ton, and the network capacity. So strategically placing this RAN will help um, will help network operators to optimize the network performances and ensure that the users receive high quality and reliable network experience. Okay. So ayan. So as you can see in the on the screen, our RAN, it 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 gives up signals to a lot of areas. So here, these RANs are strategically placed in different locations. Okay. So it serves different technology. Yeah. Okay. So now we are moving to the wireless telecommunication system. So we have three main parts for our wireless telecommunication system. So first we have is the user terminals or the user equipment. So these user equipments are the equipments or the devices that we are using every day. So this can be your cell phone, your tablets, and other devices that we use so that we can connect to other devices or to the radio access network. So we have mobile station for 2G devices, and for 3G, 4G, 5G, these are called the user equipments. So next we have is the radio access network. So the radio access network, these um this component is responsible for providing wireless connectivity required for mobile devices to connect to the core network and access these services or the services that we are using every day. So it includes a network of cell sites, a lot of cell sites, each of which has a base station that communicates with mobile devices over the airwaves. So yan. So the RAN connects to the user equipment or the user terminals over airwaves or the radio frequency. And the third component we have is the core network. So the core network is responsible for managing the overall operation of the network, or including routing traffic between different networks and providing advanced services such as voice calling, messaging, and data services. So this is usually what we call the brain of the system, or of the wireless telecommunication system. And the core network is connected to the RAN via a backhaul. So the backhaul could be a microwave, a fiber optic, copper, or a satellite. So these are the three main components of the radio access network, or of the wireless telecommunication system. So yeah, that's it. So now let's move on with the spectrum. So what is a spectrum, or the electromagnetic spectrum? So a spectrum is the fundamental asset that provides wireless connectivity. So these are have different values, or different measurements. So it is an invisible electromagnetic wave generated by radio transmitting device, and the spectrum is about frequency measured in hertz. So we have um different um measurement, or different spectrum is equivalent or has a value of different hertz, or that that we use in different situation, or in a different what do we call this, or in a different different application. So these spectrum operators usually require a license for certain frequencies for a given period of time in return for paying annual fee, spectrum users fee. As you can see, our network providers, they also use different frequencies that we will be um seeing later. So these licenses are normally 10 to 20 years in duration. But how important these spectrum are. So for example, these frequency waves, or this spectrum have different ranges. So for example, you can see a piano, right? If you're a musician, do you know a piano? So they have low notes and high notes in the radio spectrum. So the low frequency waves are like the low notes, and the high frequency are like the high musical note. So as you play different keys in a piano, we use different parts of the radio spectrum for different purposes. So if it's a do re mi, so these each keys have different purposes in a radio spectrum um range. So one key is for TV signals, another key is for Wi-Fi, some are for mobile phones, some are for emergency services. So each range, or each value in the radio spectrum is very plays a key, or an important key for different kinds of purposes. So if in a radio spectrum, there are different technologies that share space, and it it is so organized that if you are using a TV signal, it doesn't interfere with other um with other devices, or with other purposes. Like if you have a Wi-Fi, it will not interfere with the radio station. And if you're making calls, it will not disrupt your neighbor's TV. So we assign different range for a different purpose, so that there will be um there will be an organized way of range of waves that we can use all of our gadgets and technologies without interrupting uh each purpose. So it will not be so chaotic, and the world will be at peace for the wireless world in the radio spectrum. So I hope you understand that. So that's how the electromagnetic spectrum is so important and valuable to know. Yeah. So now we are moving with the cellular frequencies in the Philippines. So first, we have different uh frequencies that we are using in the Philippines. So we have 450 megahertz, 700 megahertz, 850 megahertz, 900 megahertz, 1800 megahertz, 1900 megahertz, 2000 megahertz, 2100 megahertz, 2300 megahertz, 2500 megahertz, 3300 megahertz, and 3500 megahertz. And there's just a lot of values more. So these are divided into two. You can see um red and blues um frequencies. So the red ones use FDD for frequency division duplex and TDD for the blue ones. So what is FDD and TDD? So these are mode of operations that we are using um, that we use as a duplexing technique in telecommunication. This is how we transmit our data. So first, we have is the FDD or the frequency division duplex. So in FDD, we use a separate frequency bands for uplink and downlink communication. So for instance, we can consider our mobile communication scenario. So for downlink, they transmits data from our base station to the user equipment over a specific frequency band. So let's say that our um, downlink have 900 megahertz. So if will be talking about the uplink, so the uplink transmits data from the user equipment back to the base station, and it uses different frequency band, let's say 1800 megahertz. So as you will observe, the uplink and the downlink transmission are separated in the frequency domain, so allowing for simultaneous communication in both direction. So the FDD is commonly used for 3G, 4G, and 5G cellular networks to enable efficient and reliable bidirectional communication. So again, with the FDD, we use separate frequency bands for the uplink and downlink, so we can have simultaneous transmit of data. So moving forward, we have is the TDD, which stands for time division duplex. So here in the TDD, in the telecommunication, it is a telecommunication duplexing technique. So it is used to transmit signals, receive signals on the same frequency, but at different times. So FTD uses separate frequency, while TDD uses same frequency, but the difference is it uses it's not transmitting simultaneously, but it is transmitting in a specific using specific time slots. So in TDD, we have is same frequency but different times. So the uplink and the downlink, TDD uses the same frequency for the uplink and the downlink, but separates them in time. So transmission alternates the two directions in a specific time slots. So again, FDD is like having a dedicated lanes for each direction on highway, allowing for constant simultaneous traffic flow. So if you can imagine our roads, so we are simultaneously crossing or driving in the road in two direction. But for TDD, it's like our traffic signals. So it efficiently alternates the flow of the traffic in both direction on a shared road. So that's how FDD and TDD works. Okay. So we have here the wireless telecommunication system again. So just for a review, so we have our user terminals. Our user terminals connects with our radio access networks via air interface. Then our radio access network connects with the core network via a backhaul. So this could be a copper, a fiber, a microwave, and a satellite. So we have here our three main parts or main components of the telecommunication system: user terminal, the radio access network, and the core network. So now, what is a radio access network? So the radio access network is part of the cellular network that is one, nearest to the subscribers, so nearest to us. So you can see this RAN all around you. So the next is the location is widely distributed. So as I've said earlier, these are strategically placed in different locations. So this could be in a city, a village, a highway, a rural, a hills, a beach, malls, or in the offices. So as you can imagine, there are thousands of RAN elements creates that seamless coverage and mobility. So that's how RAN works. So as I've said, RAN is all around you. But have you ever stopped or think um how these mobile devices is able to connect to the internet, make calls, texts while you are traveling? So this is all because of the RAN. So um I always said to my students that um if you're traveling and you already understand how the RAN works, you can see different or invisible signals. So Sir Richard told me that you call it the third eye if you understand already the RAN. So for me, I am traveling around. I am always on the go and traveling, and every time I see different cell sites, different RANs, I always see invisible lines. I don't know, that's weird. But see if you're out and on the go, you will likely see on different cell towers and antennas on top of the buildings, alongside the road. And these are all part of the RAN that provides wireless coverage to your mobile devices or your phone. So the RAN enables you to stream music or videos or stay connected with friends and families, no matter where you are. So it's not just limited to the cities or towns. It extends to rural areas, highways, and even remote locations, making it possible for the people all over the world to stay connected. So kahit nasa linang tayo or in the farm or at the farm, we can stay connected with our loved ones or to the people that we need to communicate. Okay, so as you can see, this RAN, you can see it in the roadside, in different provinces, mountains, beaches, or rooftops, or even inside a mall. So we also have RAN existing inside our buildings. Uh, we will talk about it later, moving forward. So before we move to that topic, um, let's discuss the evolution of the mobile communication. So um the oldest mobile phone that I encountered is 2G phones, but can you believe it that not too long ago it was a very limited we have a very limited form of communication, limited to a radio and landline telephone. So ito ata yung tinatawag nilang nagtatelebabad sa phone. Um, if may nililigawan ka, they are always on the phone. So that all changed with the introduction of the 1G or the first generation of mobile communication in the 1980s. So back in 1980s, we have our first mobile phone technology. So it used analog signals to enable basic voice calling. So these early mobile phones were large and expensive, as you can see in the photo. Um, and the network coverage was limited. So despite of its limitation, these first mobile phone technology serve as the foundation of mobile revolution that is about to come. So these uses advanced mobile phone systems or the apps, total access communication system, NMT Nordic mobile phone telephone. These are different mobile phone system or the older mobile phone system. So next is kung ano yung naabutan ko. I have is the 2G. Ito yung mga 3210 phones natin. So this second generation of mobile communication was introduced in the 1990s. So it enables us for basic voice and text messaging services. So it use digital signaling and allowed for more efficient use of the radio spectrum than the previous analog system. So it use GSM. So that stands for Global System for Mobile Communication. So there are still 2G still existing nowadays. Then there became the 3G. So it is the third generation mobile communication. It was introduced in the early 2000s. So with 3G phones, it brought us faster data speeds, enabling for more advanced services like mobile internet, video calls, and multimedia messaging. So 3G supported a better voice quality and allowed for more simultaneous voice and data services. So it uses UMTS or the Universal Mobile Telecommunication System. So after that, um after how many years, we now have the 4G, which is the use LTE. So this was introduced in 2010. So it brought us a more even faster data speeds, better network capacity, more reliable coverage, and 4G enabled advanced services like streaming video, online gaming, and mobile payments, and paved the way for the Internet of Things and other emerging technologies. So, eto, pinakang naabutan ko na rin talaga. So, these phones are the technology that are commonly used nowadays. So, 4G phones. But now, um, paute-ute, we are now introducing 5G, and most of the people, most of the phones are that are now introduced in that are now built are fifth generation mobile communication capable. So 5G promises to be even more faster and more capable than 4G, and with data speeds that are up to 100 times faster than 4G, and the ability to support a massive number of devices at once. So 5G is expected to enable new and innovative services like augmented reality, autonomous vehicles, and smart cities to transform the way we live and we work. So these 5G uses and our mobile system. So there you have it. So this is are the evolution of the mobile communication from first generation up to the fifth generation. So as you can see, each generation brought major advancement in the mobile technology, and who knows what we can have in the future, right? Okay. So each technology um in each technology so that's is the mobile communication system. But now, uh, we are I will be introducing you to the RAN, and for each generation, there are different RAN names. So if if you will remember, hopefully you have encountered or even if you have heard these RAN names, so we have Jaran, UTRAN, EUTRAN, and GRAN. So these are different names of radio access network that are used in different generations of mobile communication. So from first generation up to the fifth generation. So for 2G, um we are using uh we are using for 2G, we have what we call the GRAN, or the GSM Edge Radio Access Network. So this is the RAN used in 2G, or the second generation mobile communication. Next we have is for 3G. For 3G, we are using UTRAN, or the UMTS Terrestrial Radio Access Network. So for video calling, mobile internet, and such. And for 4G, or eNode B, for mobile broadband high-speed internet, the RAN was named EUTRAN, for, or which stands for Evolved UMTS Terrestrial Radio Access Network. And for the fifth generation, for for different use cases for EMBB, URRLC, MMTC, um the RAN, we call the RAN NG-RAN, or the next generation radio access network. So RAN has its own name for every generation of cellular mobile communication. But then again, these RAN have the same working principle. So despite of the different names, yung the fundamental purpose of the RAN remains the same. So it provides wireless coverage and enables mobile devices to connect to the wider network. So whether you're using JRAN, UTRAN, EUTRAN, and GRAN, the RAN is a critical component of mobile communications that enables us to stay connected and access the services we need no matter where we are or what we're doing. So now let's discuss the different RAN components. So first is we have a tower. So the tower is the physical structure that supports the RAN components such as the antennas and the cables. The tower structure is designed to be sturdy and stable, so even in high winds and extreme weather conditions. So this is critically designed. There's a certain computation for different towers that can handle the different components that will be installed for these towers. So the next one we have is the antenna system. So the antenna system is responsible for transmitting and receiving radio signals between the mobile devices and 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 the RAN components. So the antenna system is typically made up of multiple antennas, as you can see. And these antennas are placed on different heights of the tower to provide coverage to different areas. So these are critically planned to the height of where we are going to be placing these antennas. So aside from the antenna, we also have the RRU. So the RRU is a critical component of the RAN system. So it is responsible for converting the radio signals received by the antenna system into digital signals that can be processed by the BBU. So the RRU is typically located at the top of the tower structure near the antenna system. So aside from these two main components, these are the other main component is the cable. So the cable is another component for the RAN. It used to connect the different RAN components such as the antenna, the RRU, and the BBU. The cables are typically made of coaxial or fiber optic material depending on the specific application. So we use different cables depends on the devices or the applications. So that's it. So aside from these three, we also have the BBU, which is another critical component of the RAN system. So it is responsible for processing the digital signals received from the RRU and transmitting them to the core network. So we have the core network. The BBU is typically located at the bottom of the tower near the outer cabinet with power supply and ventilation. So aside from that, we also have um, CPRI. So the CPRI is is a standard protocol used to transmit the digital signals between the RRU and the BBU. So we have here the CPRRA. It ensures that the signals are transmitted quickly and efficiently, without any loss and degradation in quality. So the transmission component, so the transmission components of the RAN system was also um, included in the RAN. So here we have is the microwave antenna. So this includes the equipment used to transmit the digital signals from the BBU to the core network. So from the RAN, so this transmits our data to the core network. So this could be a microwave, fiber optic equipment, and the transmission component is critical for ensuring that the signals are transmitted reliably and quickly, even over long distances. Long distances. So we apply different transmission component depends on the situation of the site. So there you have it. So this is a closer look of the different components of a typical RAN system, from tower structure to the transmission, and each component plays a critical role in ensuring that mobile devices can connect to the wider network and access the services they need, no matter where they are. So um, you can visually see this if you are um, on a travel. You can see this and alongside the road, and you can figure out these components clearly because they are um visually visible around you. So the next one is we have different kinds or different classification of tower. So the first one we have is a four-legged self-support tower, or SST. So the four-legged tower is generally constructed with various of sizes of or angles for heights ranging from 45-meter to 106-meter. So the structures are engineered and fabricated to accommodate heavy-duty loading imposed of attaching microwave dishes and mounting sector antenna. So these four-legged tower can accommodate a lot of equipments, as you can see in the photo, a lot of microwave antenna, a lot of different antennas, a lot of RRU, and a lot of other components. So these kind of towers formulated to house various of accessories, including different including platforms, antenna brackets, lighting systems, climbing ladder, safety cage, cable ladder, utility mounted poles, and the height is recommended to be 45 to 100 meters. And this should be suitable for single and multiple operator usage as a trunk site. So if you're on the go, you can just simply distinguish, oh, this is a four-legged self-support tower. The next one is we have four-legged. Now we have three-legged self-support tower. So it is a lattice tower with a freestanding vertical tower with a rectangular or a triangular bases. So we have three poles and we have a triangular base for that. So this type of tower can be favorable in places that involve mounting many panels or dish antenna. So as you can see, we have different panels in a three-legged support tower. So a lattice tower can be used as electricity transmission, a cell radio, or an observation tower. So most of the towers that I'm saying are three-legged self-support tower. Then aside from those tower, we also have what we call the guide tower. So a guide tower is a slender steel anchored by steel cables in the ground. So these are what we call the guide wires. These wires, it is a guide tower and it has guide wires. So these are commonly seen in the tower industry because they provide the greatest strength, are most efficient, and are easy to install. Then aside from that, we also have what we call the monopole tower. So monopole means one. Mono means one. So a monopole tower is a simple single pole, and it is elementary design, reduces visual impact, and is relatively simple to build. So tower developers favored this tower. So this is really simple to build because you only have to build a single pole tower. So aside from these different towers, we can also see towers that are installed on the rooftops. So rooftop towers are relatively light tower or pole that is installed on top of the buildings or top up or rooftop of houses. So it is narrow, a four leg angular up to 12 meter and very light. So these towers range up to 3 meters, 3 meters up to 6 meters, that are usually used for mounting a single antenna. So the height could range from three for rooftop bipods. These heights ranges from 3 meters to 12 meters and are usually used for mounting 3 to 4 antenna panels. So you can see this a lot of this around the city, especially in Manila. Even me, I see a lot of this while riding the train, LRT, MRT. A lot of these are installed around us. So yeah, that's it. So the next one is we also have wall mount antennas, wall mount sites or wall mount equipments. So these are light cell site installed in the walls of the buildings with brackets. So you can simply distinguish this while just walking around the building. Especially in Makati, you will see a lot of this. Um, some are camouflage in the building. So if these sites are really for the aesthetic, they are painted with the color of the building, but some are not. So you can visually see we can visibly see this um installed um on the side of the buildings or in the walls of the buildings with brackets. Aside from that, we also have cell sites on wheels. So we call it cow or site on wheels. It depends on the provider. So telecom infrastructures placed on trailers, approved on road use and towed by heavy goods vehicles for loads up to 3,500 kilogram. And these mobile radio base stations guarantee entire operation in one day and restricted spaces. So we usually use this cell site um on wheels in different events, like if we have concerts or other big events that needs that caters a lot of users. So you can see this if you attend a lot of concerts, you can see cell sites on wheels around you. So next, we also have what we call a camouflage sites. So the first one is a stealth tower. So a stealth tower is a monopole tower, but in disguise. So that's why we call it camouflage. So if these are usually in urban areas when they need to reduce the visual impact of the actual tower. So as you can see on our example, this stealth tower could be um a broadleaf tree, a palm tree, a water tower, a flagpole, or a light pole, or a tower that is hidden on a billboard and such. So aside from a stealth tower, we also have what we call a water tower. So a water tower is a run of the mill with cell tower entities on top of it. So as you will observe, you can see different components that are installed on top of a water tower of a water tower. So this structure is conducive financially to communication companies because the company does not have to spend thousands of money in building a new tower structure. So water companies usually negotiate rental prices with the tower companies or the wireless carrier to allow companies to put their equipment on top of their water towers. So this is mutually benefits both parties. So these camouflage sites are usually used for the aesthetic. So so that it will not be visible enough for the users to see that we had installed a lot of components in a site on a site. And aside from all of this tower, we also have, just like what I said earlier, we also have ran inside of a building. So we call it in building solutions. So an indoor DAS, or or it is an in building wireless system, in is a site where the components are meant for indoor usage. So in an IBS or in a building, we install a lot of this antenna. This could be a panel or an omni, or in a lot of different um k- kinds of installation for IBS. So these indoor DAS covers parts of the building that outdoor macro cells can't reach. So if our cell sites outside the building can't reach the inside, um, we install indoor DAS so that we can have signals or high quality of coverage also inside our buildings. So indoor DAS installations are typically used on more significant buildings, venues like stadiums, arenas, or large residentials or commercial buildings. I designed a lot of this before. Um, and and most of it are hotels, malls, condominiums, places wherein we need to cater a lot of users. So in an indoor system, the setup looks like this. So we have what we call a radio room. Sometimes we don't have that, but in a radio room we have different um components that you will usually see on a RAN in a tower setup. So we also have there an RRU, a cabinet, a BBU, and other components that we discussed earlier. So from the radio room or from these components, uh we um we cater signals using different other components using a cable. We have different splitters, and we use different kinds of antennas. It could be a panel antenna, an omnidirectional antenna, or a directional antenna. So it relies increasingly on wireless devices for communication. So inside of a building, we can still access signals, and we can still communicate with um, other users outside of the building. Usually, this is for entertainment and work. Uh, so installing indoor system ensures strong and reliable indoor coverage that has become increasingly important because we are working, or there's a high demand of signal or communication, especially inside of a workplace. So we will explore more of this later on for its different applications and challenges that will help us to overcome our high demand of connection. So next is we have what we call a small cell or a pico cell site. So this kind of cell site is connected by fiber optic cable and mounted to an already made structure like a light, or a unity, or a utility pole. So this makes them more discreet while bringing them closer to smartphones and other devices, a benefit that will become clear as we go. So you can see most of this in a lot of buildings too, or outside, maybe around you in some parks, or some places wherein there's a lot of users, but the most efficient design, or the most efficient um kind of technology to install on the site is picocell sites or small cells. So aside from that, lastly, we have what we call a portable or private cell sites. So Singtel released a portable cell site to serve in disaster situations that are small enough to fit into a suitcase, or giving first responders another communication tool when regular communication channels are offline. So these are use especially for emergencies, so that we can still have signal, or we can still communicate efficiently while everything is offline. Okay, so those are the different kinds or classifications of our radio access network. Now, moving forward to the equipment from traditional vendors, remote radio units. So this is a closer look of the RRU. So the RRU is a radio transceiver that communicates with mobile devices over the airwaves, just like what we're discussing earlier, and is located remotely from the baseband processing unit. So the RRU is a critical component of the RAN system that is used to provide wireless coverage connectivity to mobile devices. So the RRU is essentially a radio transceiver that communicates with mobile devices over the airwaves and located remotely from the baseband processing unit, just like what I've said. So um so these RRU is responsible for converting the digital signals from the baseband processing unit into analog signals that can be transmitted over the airwaves. So it also receives and converts the analog signals from the mobile devices back into digital signals that can be processed by the baseband processing unit. So the process is essential for providing reliable and consistent wireless coverage to users. So in short, it is the one who converts signals from digital to analog and vice versa. So the RRU is mostly or typically located, if you will see, in a tower or in other setup of a RAN. So the RRU is located or near the antenna site, and it is connected with the BBU via a fiber optic cable or a wireless connection. So by placing the RRU, so this RRU, so this is closer to the antenna site, so the network operator can reduce the loss of signal strength and improve the overall performance of the RAN. So in designing these, it is more efficient to design it closer to the antenna, so we can minimize the loss of the signal strength. So mas mababa yung loss, mas maganda yung performance nung run natin. So in terms of its physical characteristic, the RRU is typically a small, lightweight device that can be easily installed and maintained. So it is designed to withstand different environment conditions, such as extreme temperature, moisture, high winds, and is typically housed in an outdoor cabinet with power supply and ventilation. So overall, the RRU plays a critical role in the operation of the RAN, since it enables our mobile devices to connect to a wider network and access a wide range of services. So without it, I think our wireless connectivity as with no would not be possible. So aside from the RRU, we also have another equipment from traditional vendors, which is the CPRI, or the Common Public Radio Interface. So the CPRI is a key technology used in modern radio access network systems, or the RAN systems. So it transmit data between the RRU and the BBU, or the baseband processing unit, Essentially, CPRIs enables the high-speed transmission of data over fiber optic cables, allowing the RRU and the baseband processing unit to communicate with each other. So again, it is it enables the high-speed data transmission of data over fiber optic cables that allows the RRU and the baseband processing unit to communicate with each other. So how does the CPRI work? So the CPRI standard defines as a set of protocols and specifications that are used to transmit data over fiber optic cables, just like what I've said. So the data is sent in the form of packets, in the form of data packets, move, in the form of data packets, which are synchronized between the RRU and the baseband processing unit. So the packets are converted into electrical signals. Okay, it's converted to electrical signals by a transceiver, by a transceiver, which are then transmitted over the fiber optic cables. So that's it. So one of um the CPRI has a lot of advantages also. So over other methods of data transmission such as copper cabling or wireless transmission. So for example, or for one, fiber optic cables can transmit data over much longer distances than copper cables, which less signal loss or with less signal loss and interference. So it makes possible to deploy RAN system in areas with poor coverage or high user density. So the CPRI allows us for greater flexibility and scalability in RAN systems. So by separating yung RRU natin from the baseband processing unit, network operators can easily add or remove units to match changing network demands. So as years goes by, um we regularly change these components depends on the demand of the current demand of network of the network. So we can also upgrade the baseband processing unit independently of the RRU. So with this kind of flexibility, it allows us for easier technology upgrades and a cost-effective way of upgrading our technology. So this CPRI equipment is a critical technology in the modern RAN systems. So as you can see, as discussed, so this enables high-speed transmission of data over fiber optic cables and really enables a reliable and efficient wireless connectivity for mobile devices. So that's how it works. That's how important the CPRI is. Oh, here. So that is from it connects the CPRI connects the RU and the BBU. Next, aside from the RU, the CPRI, now we have is the BBU. So in Iran, the BBU plays a critical um, component of Iran. So the BBU is responsible for processing and managing the data that is transmitted to and from our mobile devices. So essentially, the BBU is the brain of the RAN, controlling the flow of data and ensuring that everything operates smoothly. So in technical terms, the BBU is responsible for processing the digital signal received by the RRU and converting them into analog signals that can be transmitted over the airwaves. So paulit-ulit lang tayo, di ba? So these are the um functions of the components. So in BBU, it is more responsible of receiving the analog signal from mobile devices and converting them back into digital signals that can be processed by the radio access network. So um as you can see earlier, our BBU is connected to the RRU via a fiber optic cable or a wireless connection, and it communicates the RRU using it communicates with our RRU using the CPRI, that enables the high-speed transmission of data over fiber optics. So one major advantage of BBU is its flexibility and scalability. So using a modular design, uh, by using a modular design, network operators can easily add or remove the BBU units to match changing network demands, just the same with the other two traditional vendor equipments. So it makes easier to upgrade the RAN system and deploy new technologies as they become available. So how does this BBU looks like in physical characteristics? So they are typically large and rack mounted unit that requires a significant amount of power and cooling. So you can see them inside of a rack. It contains variety of electronic components including processors, memory, storage devices, and enables it to process and manage large amount of data. So overall, the BBU plays also a critical role in the operation of the RAN system. So it enables our mobile devices to connect to the wider network and access a wide range of services. So without the BBU, without the RAN, without the CPRI or these traditional vendor equipments, we would not be able to process, we would not be able to connect, or we would not be able to have a more reliable and efficient wireless connectivity for mobile devices. So that's all for the RAN, or the main components of the RAN. So um, we moving forward is we have the RAN and the OSI layers. So the RAN system is often divided into different layers. So each of which is responsible for a different aspect of the system. And one common way of conceptualizing these layers is through the OSI model. So which is a conceptual framework that describes the communication functions of a telecommunication or computing system. So we have this is very familiar, especially with some of our professionals and students who are now taking ECE. So we have the OSI 7 layers. So we have the first layer from physical layer to data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. So this OSI model is a set of concepts and that describes and is standardized how a computer or telecommunication system communicates regardless of how it is built or what technology it uses. So the OSI model is consists again with 7 layers. We have mnemonics for that. In Taga, the all people seem to need data processing, but in school, I'm using ang pulis sa tulay na dapa. Okay, so that's what I'm using. So um the OSI we have is let's discuss each of layer quickly. So first one is the physical layer. So in the physical layer, it is responsible for the transmission and reception of raw data over a physical medium. So this could be a copper or a fiber optic cable. For the next layer we have is the data link layer. So this one naman is responsible for reliable transmission of data over shared physical medium. So this uses protocols such as the Ethernet or Wi-Fi. The third layer could be the network layer, which is responsible for routing data between different devices or on a network. So this uses protocols such as the IP or the MPLS. The next one is the fourth layer, so the transport layer. So it ensures a reliable and efficient data transfer between the devices on a network using such as protocol as the TCP or the UDP. So we have um actually this OSI layer is divided into three. So we have the lower layer and the upper layer. So the transport layer um um is also responsible to ensure that the data is efficiently transferred from these first three layer up to the second layer. So moving forward, we also have a session layer. So this layer is responsible for like establishing and managing communication sessions between devices on a network. So this uses protocol such as the RPC and the NetBIOS. So in the session layer, again, this is where we establish and we manage the communication. So that's why it's called sessions. So the sixth layer is the presentation layer. So the presentation layer is responsible for like formatting and presenting data to be transmitted over a network. So this uses protocols such as the ASCII or the JPEG. So in a presentation layer, this is where the data usually um is transmitted over the network. So this is where all the data are happening. The ASCII um or at converting this data into the data that is needed for us to communicate. So this could be in different forms of data. So on the last layer we have is the application layer. So this layer is responsible for providing high level services and application to users. This could be our emails, web browsing, or voice calling. So this also using a lot of different protocols, but in in an easier explanation, the application layer, it is the applications or the softwares or the services that we the users use in everyday lives. So each of these layers plays a critical role in the operation of the RAN system. So it enables mobile devices to, again, to connect to the wider network. So we have to understand the different layers of the RAN system and how they work together. So we can better understand the complexities of the modern telecommunication system and how they enable us to stay connected and access the services that we need. So for me, knowing these seven layers will also help us to upgrade and innovate our or open a lot of innovation in the telecommunication industry. So if we map these layers into the different components of the RAN system, for the physical layer, in a RAN system, the physical layer here, the physical layer, is responsible for the transmission and the reception of raw data over a physical medium. So, in the physical layer, this could be the copper or the fiber optic cables. So, also in this layer, it also includes the tower structure, the antenna systems, and cables that transmit the wireless signals to and from our mobile devices. On the data link layer, in the RAN system, it is responsible for the reliable transmission of data over a shared physical medium. So it is using protocols such as the Ethernet or Wi-Fi. So in this layer, it includes the RRU, which communicates with our mobile devices over the airwaves, and the BBU, which is functioning to process and manage the data transmitted by the RRU. And lastly, in our network layer, in the RAN system, it is responsible for routing data between different services on a network. So it uses protocols such as the IP or the MPLS. So in this layer, it includes our network gateways, which connect the RAN to the core network and other external networks. So by mapping the OSI model to the different components of the RAN system, we can better understand the role of each layer and how they work together to provide us a more reliable and efficient connectivity or wireless connectivity. So this knowledge is essential for network engineers and telecommunication professionals who work with RAN system on a daily basis. So here, um, the radio access network. So the physical layer is the first layer of the OSI model, which is responsible for the transmission and reception of the raw data over a physical medium. So we have here the RRU. So in the RAN system, one of the key functions of the physical layer is to convert the radio frequency signals from analog to digital. So this is accomplished through the use of the transceivers, which are electronic devices that can transmit and receive RF signals. Um, while in the data link layer or a network layer, so in the data link layer, the system include packet data convergence protocol, so the PDCP. So it is used for IP header compression, for security, hyperlink, integrity protection. Um, it also includes the RLC or the radio link control. So it functions for segmentation, concatenation, ARQ, duplicate detection, and the MAC, the MAC protocols, which are used to segment, reassemble, and manage the data transmitted between the RRU and the BBU. So this is mostly for multiplexing of logical channels, HRQ, and so much and so forth. So while in the network layer, it includes the RRC, which stands for the radio resource control. So this one is responsible for controlling the access to the radio resources of the RAN. So it functions for broadcast, paging, connection management, mobility functions, and measurement configuration and reporting. So the physical layer, the data link layer, and the network layer plays a critical role in the operation of the RAN system, enabling a mobile devices connect to to and access a wide range of services. That's it for the radio access network. So what we have in the radio access network is the meaning of the RAN. So RAN stands for radio access network. RAN is a part of our cellular mobile network that gives mobile coverage. So we have the three significant parts of the RAN, of the wireless communication system, which is the user terminal, the radio access network, and the core network. We also have the different names for RAN, which is the GRAN, UTRAN, EUTRAN, and NGRAN for different generations. Aside from that, we also discuss the different physical structures but have the same working physical structures of the RAN. Also, the main components of the radio access network, just like the antenna, the RRU, the BBU, the CPRI, and the different RAN generations has different but interworking network architectures. And lastly, that was discussed is the OSI model, which is a set of concepts that describe and standardize how a computer or telecommunication system communicates, regardless of how it is built and what technology it uses.